and welcome again, our Kotlin and Compose lovers. Today we are having Nikita. He is from JetBrains, and he has a very good presentation to deliver to us today, and it's going to be about Compose on iOS. So let's start the session, and Nikita is going to start by giving us a small intro about himself, and let's kick into this session.
Okay, great. Hello, everyone. So today we will talk about Compose Multiplatform on iOS. But first, let me explain what is Compose Multiplatform. So we have Kotlin Multiplatform, and we have Jetpack Compose that is written in Kotlin. Booms! Compose Multiplatform. By the way, do you see an apple in this sculpture? I believe it's not right apple. This apple is much better. Let me chew the apple and swallow it. Okay, great. So it was just a little warm-up show, and now we can start. Originally, we presented this talk together with Sebastian Igner. He is JetBrains developer advocate. And honestly speaking, his part was significantly bigger than mine because I'm not professional speaker as he is. I'm just Compose Multiplatform developer. I joined this project last September because I liked very much the whole concept of composable functions. I believe it's something new, not only in UI programming, but in programming in general. Before that, I used to be a JVM developer, so I did JVM native compilation and stuff like that. So I'm quite fresh in Compose, so please don't ask me how to do in Compose this or how to do in Compose that. But with the formalities out of the way, we can get right into today's subject. JetBrains is bringing Compose Multiplatform to iOS. This enables a very cool synergy, the ability to write a user interface once and share it. So what we are going to talk today? Today's talk will contain a bunch of live demos on iOS, a look at the implementation and the architecture, and how you can get started writing shared user interfaces for Android and iOS. But first, let's do a super brief recap of the classic Kotlin multi-platform use case. We are looking at the mobile case because it's the most popular. But this concept, of course, generalizes. The idea here was to share the code that is supposed to behave the same on multiple platforms, but not give up access to platform-specific APIs and capabilities. But what was missing was a solution for when you don't want to build and maintain native UIs for your target platforms separately. Maybe because you don't have enough people, maybe because you don't have enough time, maybe because you really want to release your app as soon as possible, not fixing bugs in two separate source code bases. And that's what Compose Multiplatform enables. It allows you to implement your user interface once and use it for all the platforms you target. In our scenario, that's iOS and Android, but you can absolutely throw desktop and web in the mix as well. Because it's worth pointing out that Compose Multiplatform is actually the JetBrains initiative to enable cross-platform UI development across various parts of the Kotlin ecosystem. In late 2021, we already stabilized the desktop target for Compose Multiplatform. That gives you a great way to build user interfaces for Windows, Mac, and Linux. By the way, among the Kotlin Conf talks, you may find a talk of Victor Krop. You can do desktop too. And there you'll learn the backstory of Compose Multiplatform project that you may have already used yourself, JetBrains Toolbox. Another target of Compose Multiplatform is web. The web part is experimental. We're experimenting with Compose for JS for quite a long time. Within our samples, you may find samples targeting web. And recently, we have started to experiment with Kotlin WASM. But of course, there is iOS targets, which we'll discuss today. So Compose Multiplatform builds on top of JetBrains. Compose from Google, it's quite well-established UI framework built on 100% Kotlin and rapidly becomes standard for modern Android development. And one important point, whether you are an experienced Compose dev or one of those hundreds of thousands of developers that are learning JetBrains Compose, you are in luck. Because except for a few minor differences, the APIs in Compose Multiplatform and in JetBrains Compose, they are the same. That means any knowledge you have already translates very directly. In other words, if you've written a modern Android user interface, you can use those same skills to write a shared user interface with iOS and beyond. The cool part about this that you don't have to wait to try the technology. Because we have released Compose for iOS Alpha in Compose Multiplatform 1.4 and recently announced it at KotlinConf. In fact, it was my initiative to release Compose for iOS to exactly KotlinConf time when I joined to the project in September. But honestly speaking, in January, I was in great doubt that we are going to deliver on time, but finally it happened. So I'm really happy about it. Obviously, we'll need to talk a bit about where Compose for iOS currently is, what being an alpha release means, and where we are going with it. We'll do it in a second. But first, I think it's best if we remember this moment. Let's create a memory. And I mean it quite literally. So let me pull up my iPhone and open my Memories app. It's as you might guess, it's a Compose multi-platform application that currently runs on my iPhone. It's classical image viewer where you can swipe images, you can scroll them, etc., etc. And as a demo app, it contains some stock images, but it also contains some real memories. For instance, it's a photo that we've made with Sebastian just from the stage at KotlinConf. And we can actually see the description of that moment, of that memory. And we can also see where it was. It was in the middle of Amsterdam, in the center of Amsterdam, in a very interesting historical building. It is a former trade system of Netherlands, and so it's very exciting from outside and as from inside. And we can actually see how it looks inside. It's very amazing building. So, by the way, we can apply filters here, like in Instagram. And what else we can do with this application? We can create a new memory. So let's do it. Unfortunately, I can't see you, but anyway, let's try to make a picture now with you, with my presentation. Let me do it. Okay. And now we can share it. We can just share it and let us tweet it. And okay, that's it. But please let me also show that the same application runs on Android as well. So let me pull up my Android phone now, and let's open the same application, but on Android. Here you can see again the picture that I've made at KotlinConf stage in Amsterdam with Sebastian, and there are some other cool pictures here as well. We can also make a new photo with it, but I think that one photo is enough for today. So okay, great. Now we can continue with our presentation. All right. The main reason for this demo was to show you a few things that are already in the alpha release of Compose for iOS. As we have an actual app, I can explain the point about shared APIs more concretely. The image you see here, that's just an image composable, the same one you have already seen and maybe already used on Android. And let me be clear, it's not a similar API. It's literally the same. The green down here, that's also a lazy vertical grid that's built into the Compose foundation and behaves exactly like you might expect. We went a bit fancy with the button. Of course, we could use just a built-in button composable, but we wanted to do a bunch of customizations, so we opted for a box with modifiers. And even those modifiers are the same ones that you already see in Jetpack Compose codebases on Android. And this stretches to most of the UI topics. Animations use the same DSL as on Android. The parallax effect while scrolling, that's also just built on top of regular Compose APIs, as are the transitions and so on. So main takeaway, you are building with the same blocks here as you have on Android. That means it's very quick to get started. But we also saw some stuff that is not just Compose. Indeed, our demo app uses some platform features. You saw two examples of this in the demo where we embedded a map kit map into the details, and you saw the camera view, which uses AV Foundation, another Apple-specific API, and still we have things like take a photo Compose button on top of it. It's one of our goals to provide smooth interoperability for such kind of complex platform-specific widgets. But we also saw some stuff that's not just... yes. And talking about goals, it's worth to talk about those topics that aren't finished yet, that are work in progress. Remember that we are only in alpha. This starts from the little things like how gestures and scroll physics behave, which defines the very feel of an app. It extends further to navigation principles and transitions and complex interactions like text selection, input management, context menu, and the like. We will also want to compose apps to provide solid accessibility integrations, which includes everything from text to voice to zoom and contrast preferences from users. It's a lot of points to consider for your user interfaces to look and feel great regardless the platform. One more topic that's of course important is providing absolutely smooth performance, even on high refresh rate displays. Okay, that's what about work in progress topics. Let's also talk about other things that are used in our app. Internally, it's doing concurrency and networking, persistent, and of course, it also has a business logic. Those aren't actually Compose multi-platform topics, it's more about Kotlin multi-platform story. So since you're building on top of Kotlin multi-platform, you are getting proper native binaries on iOS. But it also means that you can't just magically expect your existing Android apps to work on iOS, especially if you depend on some Android-only libraries. You still have to turn your application into multi-platform one. And here the same approach is applied. You may use expect actual mechanism to define platform-specific parts, and you can use multi-platform libraries. By the way, the Kotlin multi-platform ecosystem rapidly grows. There is a lot of multi-platform libraries already, and they cover many of the popular use cases you might have in your app. And a special thanks to Google for bringing their JetBrains libraries to multi-platform as well. That's make it even easier to bring your Android applications to other platforms. What's especially cool is that there are some people that are making multi-platform libraries on top of Compose Multiplatform that already target Compose for iOS. You may already see Compose Multiplatform libraries for navigation, resources, etc., made just by the community. But how did we actually make Compose Multiplatform? How does all of this work under the hood? What's the interop story? So let's talk about about it. So Compose Multiplatform project started just between Jetpack Compose official announcement and its first public release. So we started early. And Jetpack Compose is part of Android Jetpack suite of libraries that lives on GitHub at Android X repository. Jetpack Compose is fully written in Kotlin. And to make a Kotlin multiplatform, a Kotlin library, as Kotlin multiplatform library, you have to define Kotlin multiplatform source sets for the targets you are going to support. So we just followed this way, and to make the story shorter, if you go now to Android X GitHub repository and navigate Compose UI sources, the most low-level part of Compose, you may find that it defines Kotlin multiplatform source sets. So official Jetpack Compose is Kotlin multiplatform right now. And yes, Google writes their code mostly in common source set. Isn't that amazing? It allows us to reuse Google's work for other targets that we are working on. Thank you, Google. You know that writing a code in a common source set imposes certain restrictions on what you can use and what you can't. So our regard to Google that they do it. Actually, we collaborate with Google in Compose Multiplatform development, and we do our development in a repository called Compose Multiplatform Core, where we maintain the additional targets supported by Compose Multiplatform. And we regularly report our changes in common code back to Google's Android X repository. And talking about additional targets, if we navigate Compose UI sources of Compose Multiplatform Core, we may note not only Android and desktop targets, but we can also note source sets for web and iOS targets that are called GS main and UIKit main respectively. By the way, among the source sets, you may also note Skiko main source set. It's actually a common source set for all our targets except Android, containing most of the code of our port. But what is Skiko? So let's now talk about Compose Multiplatform architecture. And to understand how Compose Multiplatform and Jetpack Compose relate, we first need to understand the architecture of Jetpack Compose itself. The most low-level part of Compose that deals with layout, drawing, and input is Compose UI. That defines basic blocks for UI construction. Compose Foundation is based on Compose UI and provides basic layouts like column, box, lazy column, etc., gestures, text. Compose Animation on the top of Compose UI and Foundation. And on top of it, design systems with common widgets are provided, like Material and Material 3. And to write Compose applications, you need Compose compiler, because the whole concept of composable functions is actually an extension to Kotlin language that needs compiler support. And the whole Compose system is managed by Compose runtime. So it was about Jetpack Compose architecture, about different parts of Compose. On Android, Compose is managed by Android, of course. And probably you know that Android uses Skia graphics engine for all rendering stuff. By the way, Google Chrome also uses Skia. We decided to use Skia as well for other targets for Compose Multiplatform. Skia is written in C++, so we wrapped it with Kotlin bindings and named it Skiko. So now you know what is Skiko main. This is where Compose Multiplatform comes into play. Most of the code of our port is in Skiko main source set, but of course there is some code for individual targets as well. But most of the code of Compose Multiplatform is just shared with Jetpack Compose, except some parts that are too Android-specific, like resource management, that we will talk later. And if we talk about iOS port, the whole system is managed by Kotlin native compiler and runtime. Compose is exported to an iOS application in the form of UI view controller instance, so it can be consumed by UIKit or Swift UI in any place. Let me show how to do that. So first you define your UI stuff in common main source set. Then you export your UI in the iOS main source set in the form of UI view controller using Compose UI view controller wrapping function. The function just gives Compose a canvas And Compose draws all your UI on this canvas using Skia. And returns UI view controller back to the iOS world. Finally, you just use just exported function in your Swift sources. And you may use Compose as individual screens or as a whole application like an image viewer that I've shown. But you can also embed Compose into your Swift UI screens, like in the chat app on the right, where top and bottom bars and text input are Swift UI elements, while chat view is written in Compose. That allows you to gradually adopt Compose Multiplatform in your existing projects. Kotlin interop works great here. However, it can work opposite way as well. You can wrap UIKit widgets as composable functions using your UIKit view composable function and use it within Compose views. Here you wrap iOS map view widget. Notice just pure Kotlin that references MK map view directly, so you don't need to write any Swift or Objective-C code for this. Then you may use to wrap native map in memories Compose view. And you can also wrap other complex widgets like camera or web view. But please do not overuse this approach. You know that mixing different UI frameworks on the same screen always have issues. So please don't embed Swift UI into Compose and Compose into Swift UI recursively on the same screen. But we believe that this approach should work for complex widgets that we aren't going to implement like map view and web view. Okay, but you may ask, okay, it's clear, but what about performance? Does the scheme perform well? So if we talk about performance of UI applications, we actually talk if we can fit into 60 frames per second or even 120 frames per second for modern devices. And that means that we have only 16 or 8 milliseconds to do all rendering stuff within a frame. And if something heavy appears within our rendering process, if we do something heavy in the main UI thread just for 16 milliseconds, for instance, we immediately lose the frame and users will note it and will perceive it as a lag. Now recall that Compose for iOS is managed by Kotlin native. Please note that Kotlin native is not just compiler. It's not only compiles your Kotlin sources into native code, but it also provides a managed runtime. And that runtime has garbage collector. By the way, if you appear to try Kotlin native 2 years ago and faced with the problem that it's hard to write a multi-threaded code with it, it's not the case anymore. Multi-threading semantic is the same now for all targets, and you don't need to use freeze method for shared mutable state. But it resulted that garbage collector had to be re-implemented, and it is not reference counting anymore. But classical mark and sweep, we stop the world pause, where sweep phase is concurrent, but mark phase is not performed in GC pose. So GC pose linearly depends on number of live objects. So for now, GC pose is exactly that heavy thing that can appear in the middle of the rendering process, causing your app losing frames. And unfortunately, yes, we observe now 16 millisecond GC poses on users' applications. But good news that Kotlin native team is planning to work on fully concurrent GC, and we believe that we can achieve 2 millisecond GC poses that should be enough for your applications to not lose frames. So if you try Compose Multiplatform for iOS and see that it is not performant enough, please do not throw away it immediately. But first, make sure that you compile your application in release mode. It's very important. And then you might try to disable garbage collector to estimate future performance. If you disable GC, your app won't crash immediately, and you can compare if performance is better or not. If it is not performant anyway, please share your use case, because we are relating the performance right now, and we believe it's very important for the project to be successful. We work closely with the Kotlin native team to improve performance, so provide us your feedback. And I have also an update from the Kotlin conf regarding the performance. As I said, we are relating the performance right now, and during that evaluation, we have found a couple of cases where we were losing frames regardless Kotlin native, especially related to 120 FPS devices. They are already fixed in the development version. By the way, you may actually get and test your dev builds right now. It's they're publicly available. But anyway, you may expect noticeable performance improvements for the next Compose release that is scheduled for July. Another fresh thing that the next release will be more stable, as because we found and fixed several runtime crashes. The crashes were reported by the community, and it is how exactly our project evolves. You report problems and we fix them. Now that we have even had a look of how things work internally and what to expect, it's time we get into Compose for iOS. And here I would like to do a little live demo. And first I need to change my screen for this. So let me stop sharing. And let me change my screen. Present, share screen. Share screen. Entire screen, and yes, share. Okay, great. First thing that I would like to say is that if you are going to start Compose for iOS development and run your applications on iOS simulators or iOS physical devices, you have to have Mac. It is not our requirement, it is Apple requirement. Moreover, I would like to say that that you will also need to become an iOS developer, at least on some basic levels. So you should learn what is Xcode, because Compose Multiplatform uses Xcode for Compose Multiplatform builds. You should learn how to configure projects from Xcode. You should learn some Apple terminology, like what is bundle identifier, what is development team, how to enroll to Apple development program. By the way, you can just use free Apple account to start your iOS development. But how can we get started with Compose for iOS development? And the answer is, of course, on our Compose Multiplatform homepage, where you can explore some information about it, but it also contains a direct link to our template projects. And we will go to the iOS link, and we will see here our Compose Multiplatform template project targeting iOS and Android. In this case, we would like to explore. And you may just clone this repository and open it Android Studio. I have already done it. Let me check. I have already done it, and let us. It's just that project, and then let us first run it. On Android simulator and on iOS simulator. And we can see the application, that sample application for Android and for iOS. You see they are the same. We have a button, and if we click on a button, the text changes, and we see Compose Multiplatform logo showing and disappearing. Okay, and the same is for iOS simulator. Okay, great. And let us check. But by the way, before you start, please let us check that the environment is set up correct. It can be done by KDoctor tool that comes with Kotlin multi-platform that checks operating system, how Android Studio has a Kotlin Multiplatform plugin installed that enables your iOS development, etc. And if we have all green, we can start development, right? And now let us check the project structure. Actually, it's classical Kotlin multi-platform structure where we have Android app module, we have iOS app, and we have a shared module. iOS app contains, for instance, Xcode project. It also contains some Swift sources, but you don't need to touch them if you would like to write the whole application in Compose. But you may need it to change them in the future if you'd like to customize your application somehow more natively. But actual code is resided in shared module that has three source sets: Android main, iOS main, and common main. In Android main and iOS main sources for platform-specific parts, but in a shared, in common main, we have actually our application logic. And then let us look on it. And we see that it is classical Compose code that starts with material theme, we have column, we have state, we have button and animated, and then an image with animated visibility inside of column. If we click on a button, we change its text and we show image. Okay, but here we also see two things that are not just regular Jetpack Compose. First thing is get platform name that is declared as expect function. And we have two actual implementations for it. One is for iOS and another one is for Android. And another thing is how we reference resources. If you use Jetpack Compose, you will reference it with R class, but R class is very Android specific. So, but we wanted to provide you a possibility to reference resources from common code and from shared and from common main source set. And for that, we provide a Compose Multiplatform resource library that does resource management for you for all targets. Now the library provides very limited functionality, but we would like to extend it in the future. For instance, now it has an issue that for iOS you need to use, if you add some resources, you will need to use pod install. You should call pod install from your iOS app folder to get all your resources updated. And we will fix it in the future. Okay, great. But let us also, let me also show you that we can actually debug this application even on iOS simulator. So let us start native debugger for this application. And it will stop at the breakpoint, and we can see now stack of the current thread. We can also examine threads for other threads. But let us find hello world string within the debugger. Top of the stack is some compose magic because we are now in a remember composable function. So let us find an appropriate frame where greeting text is declared. And here it is. Please note that by keyword maps a local variable to a field of an object, and debugger shows exactly that object. So we should find our hello world text within fields of that object. And here it is. So we can actually debug our applications even on iOS. But we can also profile our applications. And we can profile them using just standard profiler instrument that comes with Xcode called instruments. So let us choose it, and let us start profiling our application. Let us start profiling. As you see, nothing happens on the screen, so we don't see any CPU consuming except some suspicious peaks. And we see that it is just GC poses. Actually, it's just GC poses. But let's make something happening on the screen. Yes. And we see that CPU starts consuming, and let us check what is inside. Personally, I don't like how instruments shows profiles, but fortunately, there is an amazing app called Speedscope app that can import instruments profiles and show them as flame graphs. And what we see here, we see that we do some drawing. We do some drawing using scale layer, and finally we do compose scene render. Let us also check what are hot methods. And here we see GC, we see memory allocation GC again, but also we can find that Compose also does its work. So actually we can profile our applications using just standard tool called instruments. And finally, let me also show you that we can actually deliver 60 frames per second, at least for this demo. And for that, let us loop the animation, and we can do it using launched effect, where we will wait while it shows, and then we just change the state to opposite. And let us check that it works on Android first. Let us check that it works on Android. Oh, yes, it loops now. And to show you that actually this animation brings us 60 frames per second, let us open this project from Xcode. We have Xcode project, so we can actually open it within Xcode. So let us open it, and we'll run it on my real iPhone device. And let us first check that we compile our application release mode, because we can deliver 60 frames per second or 120 frames per second only in release mode. And let us run our application on my iPhone. And build succeeded. Now it should show open up. Where it is? Yes. And you may see that, yes, it's first we have an infinite animation, and we actually deliver 60 frames per second. And we can check it just from regular Xcode instruments. Let me, by the way, to show you my phone. Yes, it works. Okay, great. Okay, great. And finally, I have just a couple of words to in the end of my presentation. For that, I need to change my screen again. To change my screen again, and top screen and share screen, entire screen, and here we are, share, and new presenter view. Okay. Finally, I would like to talk about a couple of things. First, let's talk about the look of your app. Because as you saw, that thanks to canvas-based rendering, by default, you are getting the same design rendered on both platforms. The widgets you get out of the box are the same ones and that already exist in Jetpack Compose on Android, Material and Material 3. But that's just the current state. You already have two roads to go from here. You can either do consistent branding between your platforms, have the same design for both platforms, or you can provide custom scenes from each platform. The look and feel of an app is, of course, a key topic, and we actually have not made any decision about providing native or common-looking UI elements yet. This is a commitment we don't want to make before gathering feedback from all of you. But secretly, I am hoping that we all come together and just agree on one great looking user interface paradigm like this. I believe it's the best one interface paradigm. But of course, it's a joke. But really, do join the conversation and provide us your feedback, what you expect the most for Compose Multiplatform to appear. And if you're an app developer, go and experiment with Compose Multiplatform and see how you can benefit from sharing user interfaces in your apps. Reminder once more that this is an alpha release, so expect some things to be not quite ready yet. But as you saw, there is a lot of things that are working just fine. So help us evolve Compose Multiplatform into something that is useful and joyful for you. But yes, maybe don't use it for production for now. So we know that some folks like TouchLab already use it in production. So do what you want. Do what you want. I'm not your dad. Okay. So you can get started by going to Compose Multiplatform page, and it's just a few clicks to the issue tracker from there. We also want to invite you to come and join to our Compose iOS channel, Slack channel. We really want to hear from you. And for your own exploration, we have prepared a number of examples that you can explore. For instance, it's an image viewer or my memories app that I've shown you today. It's a chat app that I've mentioned today. It's some classical application like To Do or some fancy one like Code Viewer, etc., etc. And there is also a port of Compose, a port to Compose for iOS of official production sample for Kotlin multi-platform. It's in a separate branch. You can explore it as well. So finally, let's sum up what we have learned today. So Compose Multiplatform for iOS is released in alpha. That allows you to write shared user interfaces between platforms. But you still can interoperate with underlying platform. And don't expect that everything to work perfectly, but do explore and give it a try. Get involved in the future of Compose Multiplatform. So thank you for your attention and your questions.
And
thank you
for the great session. It was a very enjoyable session that I enjoyed myself. And we do have one question from Mohammed Osif. He is asking on iOS, UI is rendered via Skiko, which is a Kotlin binding to Skya. We
Yes,
saw
yeah.
that this engine caused issues with Flutter. And so they created Impeller engine, which is the new one. Are there any plans for this problem?
Yes, thank you very much for the question. We know about that Flutter is moving to Impeller, but it's interesting that Android is still on Skia, and I don't see any movements from Google to Impeller for Android itself. So what we think now that now we are focusing that on providing you almost the same functionality that you have on Android, and it also should behave, maybe should behave the same for all platforms. So you actually have a Skia rendering engine on Android, and for now we think to keep Skia for rendering, but of course we would like to add some optimizations. For instance, we would like to add optimization for shader pre-compilation, because the most problems from Skia is that for first, when your UI is opened for the first time, you may see some lags because of shaders compilations, and we are going to work on this problem. But maybe in the future, but not now, if we improve, Impeller will prove that it's really brings some undoubtable benefits, maybe we will move to that as well, but it's not near future. Not near future. So thank you for your question. Other?
Okay. Yes, I had no question anymore. So please, if you don't have any questions, I believe we've learned a lot in this session, and there are a lot of information that we need to understand and and to compute. But of course, with new information, we there are some questions that we need to ask, so it will be easier for us to digest this information.
Okay, let us ask me.
Yeah. So and until then, till you have any questions, you can ask our attendees 2 questions for a couple of gifts.
So will we have some other questions or not?
No, there are no questions, and we are still waiting for any questions until our attendees send us new questions. You can ask the attendees 2 questions for a couple of gifts.
Should I ask questions? It's interesting. I haven't thought about that. What questions should I ask? Okay. But I believe that we can just give the present to the person who already asked the question, because he's a brave guy, so we can give him a present.
Okay.
But because I don't know what to ask, sorry. Because it was not my goal to teach, but to provide information. So
yes, of course, and we need to make sure that our attendees did absorb this information.
Okay.
Yes. So I believe no one have any other question so far. Please remember that we are going to have our next session in about 10 minutes. Please make sure to attend. And I shared the session link. It is for those who are starting using Compose. So we'll starting using creating a small application in Compose with our speaker from Palestine, Gaza, Qamar. And please, we still have a couple of minutes. If you have any questions at all, I believe Nikita will be more than happy to answer it. Like he was more than happy to give us this beautiful, enjoyable session.
Maybe we can talk about our future plans, for instance. I don't know, in the last 10 minutes. So actually, yes, what we would like to achieve, you know that now you can't just make your Android apps magically working on iOS, because different platforms on iOS we use Kotlin native and not JVM. So all JVM, the most of JVM libraries aren't available. But we would like to achieve. So you will need to transform your application. But what we would like to achieve is to so your transition from Android application to iOS target as well will be as smooth as possible. So actually, we also need some feedback on this subject, because what we need to learn from you, what if you start to port your Android applications to Compose Multiplatform, we would like to learn what the most pain points from this transition from Android to iOS. And if you have really if you have some problems with performance, we will be also happy to check them and fix them, because we fully understand that we need to provide great performance for iOS.
Okay, we have another question from Abdul Wahab Zaid. He is asking, is there a plan to release Compose Multiplatform in near future?
We would like to regularly release some minor releases, so you may expect next release in July. And yes, we are going. Actually, our release cycle is about 3 months. Every 3 months, we provide a new release with some fixes, with some new features, etc., etc. Yes. Thank you for your question.
Thank you, Abdul Wahab, for your question. And I believe, yes, it is something that we did learn by the end of this session, that we need to share our feedback so we can improve the timeline, and we can have these updates in the near future, because they are working on something like a black box, but so they need outsiders to have some problems, so they can fix these problems, and you can have it in a pretty sooner time frame. So our feedback is important and it's needed. So please contribute by trying these new features and provide your feedback.
Great.
I believe Abdul Wahab is liking the response for his question. Okay, if you still have no questions to send to our attendees, I believe we can close our meeting today. And thank you very much for this enjoyable and delightful session.
Thank you. Bye. Bye all.
Okay, thank you. Bye. See you in the third session. See you guys. Bye.